ready to sort of share your.
Yeah, certainly will. So thanks everyone for coming along and dialing in as well. What I was not asked to do, I think anyway, was to come along and try and give you a bit of an insight into the day-to-day challenges, a day in the life of a maintenance engineer. That's something that's pretty difficult to do actually, for reasons that hopefully will become clear, but I've come at it from a few different angles as we go through the slides. So in terms of what I'll cover, I'll make it a very brief career overview because you've already had that a moment ago. I've then got a little bit on just high network rail maintenance. It's structured in Scotland, just for those of you that aren't aware, maybe help put things in context. What does a day in the life entail? And then I've got a series of case studies, just kind of interesting experiences that I've had throughout my career, problems that we've managed to overcome, and then just close off with a couple of sets of thoughts on what I see as the key medium to long-term challenges and a few little pieces of advice that I would personally have anyway for a maintenance engineer. So moving on then, a lot of this, as I say, has already been covered by David, but started off in the railway in 2010 as a graduate engineer, working on in York originally, doing a maintenance rotation, which was really 6 months, finding out what everybody does, which is something that proved very, very useful actually late in my career, because that's one of the biggest challenges in the railway sometimes, is finding the right person to speak to. And often once you do, the problems get solved very quickly. I moved on to Edinburgh Waverley. The refurbishment project at the time involved the roof at the main station, and also on platforms, I think it's 8 and 9 under Market Street Bridge was getting a new roofing put in as well. And then I moved on to Glasgow Central platform refurbishment, which was really a resurfacing project, but on certain platforms it involved stripping the platforms right down and rebuilding them with new precast slabs, etc. So that was all really useful. But then after that, I moved into maintenance as performance assurance engineer, and within a year or so became the assistant track maintenance engineer at Glasgow Central. Then moved on to Edinburgh after 3 years as track maintenance engineer. So that was a big change, going to a new area, a new team, taking responsibility for this section, including 125-mile-an-hour lines. I used to think as an assistant, I'm kind of doing everything the TME does anyway. This won't be too bad moving on. But what I didn't realise was that once you're the track maintenance engineer, you suddenly have to make all the decisions. And that's probably the one thing I wasn't getting exposure to. I then had a year in the West Highlands as track maintenance engineer. That certainly ranks amongst my favourite years of my career so far. Certainly the track walks were fantastic. I managed to walk all the way from Bridge of Rocky to Malig during that year, not in one go, obviously, miles at a time, but that was a fantastic experience. And that included some off-track responsibility for the whole of Glasgow DU as well, which off-tracks fencing, vegetation, drainage. After that, I went into a section confusingly titled Glasgow East, but which really covers the north of Glasgow, Queen Street Station, E&G, and then all the North Electric suburban lines too. And then in the last year or so, I've been the infrastructure maintenance engineer, which is the next level up above track maintenance engineering. It's where all the disciplines within maintenance come together. So now got accountability for track signalling and telecoms. In terms of how Scotland's structured, so a bit of a crudely drawn map there, but hopefully the point gets across. The maintenance organisation split into 4 different delivery units: Glasgow, Perth, Edinburgh, Motherwell. They're all quite different and unique, I would say, different sets of assets, challenges. So you can see in the track miles for a start, Edinburgh, Motherwell, Perth, much higher than Glasgow. And then look at the track categories as well, where actually Glasgow looks even further behind in some ways in terms of Cat 1 and 2 track. But where there's another difference is in terms of the train running comparisons, in which case Glasgow is much higher than anyone else. And it really just shows the different level of challenges. And certainly for us in Glasgow, we've got areas like Highland, for example, where we can have a relatively innocuous failure that can quickly add up to tens of trains being delayed. This is the organisation within the delivery units. So we start with an infrastructure maintenance delivery manager who's got a number of direct reports, including the infrastructure maintenance engineer, which is myself in Glasgow, reporting into the IME, the different maintenance engineers. So I've got 8 of those with different disciplines, and each maintenance engineer would typically have an assistant engineer who has a technical team and a number of section managers, and reporting into the section managers, the supervisors, planners, and the technicians that work out on the track. So what does a day in the life entail? So really it all boils down to one thing, and that's ensuring that trains run safely and on time. And if we can do that, then we're doing our job. Obviously life's not quite that simple, so there's a lot of different things that feed into that. In terms of the safety side of things, compliance is one big factor. So compliance is ensuring the maintenance regime is in line with standards at all times. Inspections, a big part of the job, particularly as a track maintenance engineer. It's a real form of assurance, making sure your asset is in the condition it should be. Making plans, making sure the asset gets what it needs. So that can be a maintenance, but you also have an input into renewal plans, a very big input into those in terms of helping the asset management team identify what sections of track need what work in the longer term. Investigations, so things do go wrong from time to time, of course, so important to learn from them. So investigations are actually something I've quite enjoyed over the years, albeit some of them in difficult circumstances. And competency as well. So making sure your team have the competencies that they need, and ensuring that you have a plan in place that keeps that level of competency in place in the long term, because of course people move on, and so that needs to be taken account of. Performance is the next big part of the job, very close second to safety, and the two really go hand in hand. Asset resilience, failure investigations. So anytime we have a service affecting failure, we put a lot of effort into investigating that and make sure we understand why it happened and what can we do to stop it from happening again. Use of data is certainly very important in terms of understanding where you are, both in terms of performance that affects trains and also just the performance of the condition of the asset. Response, again, when things go wrong, we need to make sure that we're able to respond to them quickly. We can't have trains stranded with hundreds of passengers on board for obvious reasons. And weather mitigation is something that's probably become bigger and bigger over the years in terms of the number of named storms and of significant impact. That's something we always have to bear in mind and make sure we're prepared for. And there's plenty more besides that too. And unpredictability is probably one of the key ones I would use. So probably, certainly as a maintenance engineer, you would start on a Monday expecting to spend your week on one thing. More often than not, at least half of your week would end up doing something totally different. That's something I've always enjoyed. Some people maybe wouldn't enjoy it so much, but that's very much the job. So this is more like a week in the life on this slide. This was for the track section manager from my time at PWI Glasgow East. Demonstrates the volume of work achieved in the course of 1 week. So there's 4 4-week defects, in this case they're real defects I'm talking about, which involve putting in new lengths of rail. There's a 26-week defect, another 3 4-week defects prepped, mitigated and replanned. I say that because those defects actually fell down and didn't go ahead as they were planned due to a late running train, which is just one example of some of the things that can happen that are really out with your control in maintenance, and you have to be able to respond to them and change your plans. That's that unpredictability I mentioned, and there's been a tamper in the area as well that week. So And that's just what was delivered during the week. That all of that work takes the previous week to preparation in terms of getting replacement rails to site and all that side of things. So a lot for on a small team to be concerned about. So I'm going to move on a little then and go through the case study. So I think there's 10 of these. The red dots just represent where they work geographically across the country. I'll go through each one in turn, try and summarise what the problem was, how we overcame it. And I've also tried to pick out this kind of key learning point from each one as far as I could. And on that subject, before I even go into the first case study, there was one learning point that I haven't really followed particularly well myself, which is always take lots of photographs. That'll maybe become apparent in some of the slides, but I'd maybe qualify that. I do have lots of photographs, but maybe good quality photographs would be a better way to put it. But in all seriousness, if that's something that's just absolutely invaluable to look back on, is a good library of pictures. A picture paints 1,000 words, as we all know. So the first case study, if you like, was Glasgow Central S&T. You can see in the picture there, it's quite a complex arrangement, and as many of you know, we call that the jungle. I don't know who came up with that, but quite a good phrase, I think. So obviously, just being the approaches to Glasgow Central, it's an iconic part of the railway. So being in a position to maintain that is something I think take immense pride in. As I mentioned earlier, for about 3 years, I was the assistant TME in Glasgow Central, and which this was one of a major part of that section, of course. So very complex, full of custom geometry, all sorts of unusual arrangements like double slips, tandem switches, etc. The signalling, the overhead line, all of that needs to tie in. Very, very complex stuff. But I would say, I think present day, we maintain it pretty well. As an example, month of August, we only had 9 minutes. Annoyingly, I'd like it to be 0, but 9 minutes from points failures, which given the age of the infrastructure and so on in there, I think is quite impressive. And over this summer, we have had a few hot days. We didn't have a single heat-related defect at any of our IBJs, which if we were to go back to the time when I was the assistant TMA, we certainly had more than 0 anyway. Probably getting close to double figures anyway. So all of that's been achieved over the years through proactive programmes of work. Good working relationships between PWI and S&T have been really important. We've got to have those two departments working together, because ultimately, while we've got our own parts of the asset, we're all maintaining the same thing. It's all one railway. More specifically, going back to my time as ATME, one of my responsibilities in Glasgow Central was looking after a team of 53 and 54 inspectors. 53 inspections relate to derailment risk at sets of switches. So a set of switches is changing the direction of a train, and if conditions are wrong, if you like, then what will happen is the train wheels will climb over the top of the switch rail and derail. So this 53 inspection is all about ensuring that those conditions do not occur. So it's looking at contact angles with switches, amongst other things. 54 inspections are around crossings. So a lot of most of our crossings are cast manganese steel. So you cannot ultrasonically test them for internal rail defects. So those type of crossings rely on visual inspections to identify defects. Up until around 2010, Network Rail had maintained dedicated 05354 inspection teams, and then that was taken away during a reorganisation. But in Glasgow Central, we chose to keep that team in place as a local arrangement due to the extreme risk that we felt it was given the volume of S&C. So one of my tasks as assistant TMA was to manage that team. This is an example of a bad week throughout the week and a good week in the end, because it worked out quite well. But during the history of 53, the 53 standard, the 053 standard, which dictates 53 inspections, there's been quite a lot of changes in terms of how we classify defects as knowledge and research has moved on. One of the most memorable of those was back in 2015 when we started to apply a requirement for a minimum switch topping height. It could be no more than 20 millimetres from the running surface of the rail down to the top of the switch tip, which is in the top left of the slide there. There were quite a number of switches across Glasgow Central which had historically been ground to remove defects, which meant that they then failed this check, which wasn't previously been made, and led to quite a bow wave of defects. This particular week in question started off with something actually that was nothing to do with the 53 inspection. We had a serious defect on a fabricated crossing, so we had to make arrangements that was found on a Saturday night, and we had to make arrangements to get that repaired. But then on the Sunday night, we managed to find 3 different switches which failed the new topping height check, all in the one night, and all which had to be resolved within 3 days, going by the standards of the day. So the first thing I did on the Monday morning was to liaise with our operations colleagues and understand what the impact of banning these switches to use would be. So 53 is the risk is in the facing direction, so there is always the option of banning that switch to facing roads and mitigating that risk. Basically, we were able to ban one of the switches, which was 334, without any significant impact, so that went ahead. And we were ultimately able to repair that switch by repairing the weld repairing sideway sky using an automatic welding machine. But that took us up until the 12th of April, so that was 2 weeks away. But we were able to mitigate that using ban to facing roads. The other 2 switches were going to cause chaos essentially if we banned them, which was 372 and 376. So we had to find a way of getting that resolved. And we didn't have the luxury of waiting until a Saturday night when there was more access, so it had to be done within the midweek access time. So again, our operations colleagues came along to help us. We were able to get some access organised, which allowed us to get in a little earlier than normal on 372 and strip the switch out, and get that replaced midweek within about a 3.5 hour possession. And then 376 alpha, we didn't have a spare switch, so the solution there was to plain line it. And again, we had to make arrangements to allow the early London train to get out of the station and run round about us. So say safety came into play there. So we put all sorts of arrangements in place with site wardens and so on to make sure that the team was safe. And by the end of the week, we'd mitigated all 3 of those serious defects and kept the trains running safely and on time. I think the lesson from that one and from my time in Glasgow Central, especially something that actually my TME at the time used to say to me, is to remember there's always a solution. I think no matter how difficult the challenge, to get your heads together, you usually find a way out. Secondly, this is one from Edinburgh Waverley when I was TME in Edinburgh. This was geometry theme. So track geometry, most of you will already know this, but essentially it's a measure of how smooth the track is. And we have faults, discrete faults called level 2s, which in the case of a truss fault, for example, would be 50 millimetres. And we're measured on how many of those we have at any one time. The graphs show the reduction that we managed to achieve in the Edinburgh Waverley section over the course of a couple of years. I was looking back at this thinking, what did we do there to really achieve that? And the answer is, I don't think there was any golden bullet, if you like, but what we did do was we were very consistent over a number of years in terms of golden trace reviews, taking advantage of the fact that we had 4 weekly recordings, which were relatively new back then. Some people don't like them because they feel like it gives you a higher workload, but the really satisfying thing with having data that regularly is that you find out very quickly whether your attempt at a repair has worked or not. It's satisfying when it has worked, and even when it hasn't, it is in a way because it allows you to go and try something different. We were also, once we got our numbers of level 2s, which are your time-bound faults down, we were able to start focusing on level 1s, which are your corrective maintenance, smaller faults, which can be very difficult to find actually, particularly on featureless CWR. And we were able to use PLPR, which is plain line pattern recognition. We still get this, but this was quite new at the time again. And this is a train which does a visual inspections. It's triggered by dip angles in the track, so it senses the dip, takes a photo and presents that ultimately to the section manager. Those photos obviously align with where the level 1, the discontinuities are, and allow you to help identify whether that's a weld, for example. And in some cases, we could actually use that to determine that we'd gone to the wrong place, because you could tell that there was an insulator or something sitting on the end of the sleeper which hadn't moved from one to the other. So able to use that technology and that wealth of data and quite effectively bring the numbers down, as you can see. I think the lesson safe from that one, and this again is applied at numerous times in my career, but marginal gains soon add up. So quite often you feel like you're making a tiny little improvement here and there. Within the space of a few months, it can really be amazing how quickly you see an improvement. This third one was from my time in the West Highlands. This was a landslip near Ardloe, between Ardloe and Crewmarnock. This was in August, and it was the first day back from a holiday actually. So a baptism of fire. We'd had a very heavy rain on the Sunday night in the area, and the track section manager, John Smith, who's on the left in the photo, lives locally, so he was using his local knowledge, was quite concerned about the level of rain that he'd seen. So he actually took it upon himself the following morning to contact control and say, do not send the first train, which is the sleeper, through until I've checked the section of track. So held the sleeper back. John went out, checked the track, and sure enough, find this huge washaway. So really excellent intervention there from John, to say the least. My involvement as the TME there was really to take initial control of the situation and gather the relevant people together for a site visit. Obviously, earthworks designers, all sorts need to be involved in it, and it ended up getting taken on as a project over the course of a couple of weeks for the environment to be built back up and reinstated. At the end of all that, made a point of nominating John for Employee of the Month, which was really the least we could do, which he won, which was good. And he also got a visit from Michael Matheson, who some of you might have recognised in the photo, who was the Transport Secretary at the time, so that was a nice moment. I think he's the record holder for the highest price paid to watch an Old Firm game. I would put it down, something like that. And then the lesson for that one's really never underestimate the value of experience. So that one was just a hunch from the local section manager. I think I'd better go and check that bit of track and look what we find. The next 3 case studies are going to be about my time in Glasgow East. So this is just a kind of introductory slide. Glasgow East was a particularly challenging section. It's got a lot of track in tunnels and on slab track as well, in low-level tunnels throughout Glasgow. There's a second photo there of the track, which I think is a relatively good photo for me, but it's got a football in the middle of it, and I think that's the reason I took the photo, to be honest. I have no idea what that was doing in there, but there you go. So the slab track has all sorts of challenges, and being in subsurface tunnels, it's very wet as well, so not a good combination. There's lots of suburban rail which is relatively slow speed, high curvature. You can see the reverse curves here. It's through Partick Station, and all the difficulties that come with that, and quite a high level of water management sites too. So believe it or not, there is a railway in that top right-hand one. That's at Dalmuir Tunnel. The railway passes under the canal. That's a relatively regular occurrence still, that flooding in there. I'm still trying to solve that one. And then the one at the bottom right is at Bowling Station, which was a very regular occurrence, but touchwood, we have managed to solve that one now by improving the culvert inlet arrangements. So the first part of Glasgow East was rail defects, and what we did to address what was a pretty dire situation when I took over in 2020 for various reasons. Various things had conspired, and we got to the point where serious rail defects, that's defects requiring a speed restriction, really had peaked. And as you can see, we managed to bring that back under control pretty well. And then beyond serious rail defects, the next stage you have is broken rails, which is really what we're trying to avoid. Again, peak at a similar point in time, which has come back relatively under control, although still a little high. So what we did to try and address that coming in 2020 was, looking back on it, was a bit of a three-phase approach. To be honest, we didn't quite plan it out that way in advance, but it certainly worked out quite well. So the first thing we did in 2020 was setting up dedicated re-railing teams. So that was a re-railing team, not to do discrete defects, but to target putting in long strings, 709 rails, targeting areas that were given as the most difficulty. So places with really heavy RCF or rolling contact fatigue and heavily side-worn rail was two of our main areas of focus, as well as corrosion. RCF and sideware in particular caused a lot of difficulty, because if you did get a discrete defect in the middle of that length of RCF, it's very difficult to repair that using a short length of rail. You typically have to suddenly find a long piece of rail to get to a suitable welding position. So we set that team up. It was largely made up of a contractor resource, but we put two of our good staff members in charge of that to supervise and plan the work, and they got busy installing long lengths of rail. That was also COVID. Of course, COVID was in 2020, so that actually provided us a little bit of an opportunity in many ways, and the track access was a little bit longer because the timetable was reduced for a period of time. Moving on to 2021, as we started to get more control of the situation, we transitioned that re-railing workload onto the maintenance sections. I'll also cover later on something we did to give the maintenance sections a little bit more capacity. And then from 2022 onwards, we were getting even more under control. So we started to try and move on to a more proactive footing still and focus on more minor defects, we call retest defects, which can be weld repaired without the need to find rail and move it to site and install it. Kind of key results over the last few years, it's reducing the number of live rail defects in the section from 483 to 339. Quite a significant decrease there, and that does make a difference. It's a sort of snowball effect as well, because if the section manager is getting a lot of, if you've got a lot of small defects, they all get bigger eventually. So it means a higher volume of defects that the section manager's got to react to, which then distracts from other maintenance tasks, and it just all gets worse and worse and worse. And the RCF, so rolling contact fatigue, we've got a system that tells us how many yards of rolling contact fatigue we have, and we managed to reduce the amount of RCF in very severe, and heavy categories, which are the worst categories, from 3,568 to 1,473. So that was really huge. I think that was a big factor in things. This was a little picture I made up as well. This was actually later in the process in 23-24, but we actually across two sections installed enough rail to build an arch over Ben Nevis, which is quite an impressive way of putting it. This one I've put trust in your strategy and give it time to work. It's quite a lot of knee-jerk stuff can go on in the maintenance operational realm. And to be honest, it probably took about a year of going down this very expensive re-railing strategy for it to really start showing through in the figures. But I think eventually it really did work. And I'm just glad we managed to keep it going and didn't have to stop because we weren't getting immediate results. This one here is again related to Glasgow East and track access. So track access was a big limiting factor. We had, for 12 weeks of the year, we had the Sandite, the railhead treatment train, which ran about, it's the red dot here, running about Glasgow. In the middle of the night, as you can see, 3:30 in the morning, went from Airdrie out to Dalmuir, back to Highland, for good measure up to Mulgai, and then back out again through the Argyll lines. So for 12 weeks of the year, that was absolutely decimating our track access availability. And we felt that we were getting to a certain point and then going back. So 2 steps forward, 3 steps back, really, after that 12-week period. So we tried for a couple of years to get a change, unsuccessfully. Then one day, the managing director at the time was looking for in the delivery unit, just looking for problems that we had, and I happened to have that animation, if I could call it that, ready to go. So I showed it to him and made the problem that we had quite clear, and he went away and put relevant measures in place to adjust things, basically. And the solution we came to was that instead of doing all that back and forward in the middle of the night, it would go up to Mulgai and sit there for 3 hours. So all of a sudden we had about 60 extra 3-hour shifts, and they were centred on that key area that I mentioned in Partick and Highland as well. So massive difference. And this was some of the immediate impact that we saw just year on year. So you can see previous year when the old running pattern was in place, our time-bound real defects actually increased throughout the period in question, but we were able to keep reducing them when we had the new arrangement in place. Got more rail changed, and just top 21 backlog, which is key compliance tasks, was much lower as well. So a massive success all around. Moving into the last year, there was a desire to go and put the treatment train onto the Balloch branch, which would have cancelled out most of those benefits I've just mentioned. So we were able to work with ScotRail and the Seasons Delivery team and come up with an arrangement where we, within maintenance, would operate this Sand Rover machine 3 nights a week on the Balloch branch, which supplies the treatment to the rail and avoided the need to cancel out all that benefit. So a good example there of being able to work collaboratively. If we hadn't been able to do that, we were going to see roughly 65% reduction in track access time around about that key Highland Partick corridor, which would have been pretty unthinkable. So the lesson there for me was have your problems well articulated, ready for your big moment. So having that animation, I think, which I've been generous calling it an animation, but just having that ready to go when I was asked what are your problems, really led to great things in that case. And it reminds me of something we were trained in as a graduate, right when I started. It's called an elevator pitch, which is to try and have your problems ready so that if you met somebody important in an elevator or a lift, you'd be able to get your point across before you stepped out again. Finally, for Glasgow East, this is well, it wasn't simple to achieve, but relatively simple to explain. So one of the many issues that was combining to the problems that we were having was that the whole area from Helensburgh through to Airdrie was managed by one section manager and one very large maintenance team. And the workload had really just added up to become too much to be funneled through one person. As an example, there was one point in time where we received 16 4-week defects in the space of a couple of days. So that's essentially a whole month's worth of planning out the window to start again. So we were able to make a case to split that section into 2 and have one section based in Glasgow and one based in Dumbarton. It wasn't a significant change in total headcount, so it was a case of creating two smaller teams, but each with their own section manager and supervisor. And I think the lesson from that one for me is often cases of small, high quality teams are really much better than having these huge, lower quality teams, which was the situation we'd ended up in for various reasons. Next one, still with Glasgow East, but this is Cavaliers West Junction, which is on the Edinburgh-Glasgow main line. So we were experiencing quite a lot of defects in the crossings, so cracked crossings and rails at the joints, which we needed to do something about. The junction's about 50 miles an hour. It's inherently got quite a number of challenges. So it was renewed in 2006, I believe, but nominally it's CWR, it's a stress layout, but it does have a huge number of joints within the design. A lot of those joints are very close to the crossings, which was leading to a lot of movement. And you can see from this overhead view, you can see the amount of voiding that we're still having today. The other thing, that junction, it's got a couple of fixed diamonds, which are always a little bit more susceptible to movement, I think. And it's also built across a bridge, which I'm sure doesn't help either. So I mentioned that there was a lot of joints within the layout. So what we decided to do was number them all and label them all, and that led on to carrying out a risk assessment of every single joint. I think the total number of joints was about 60, so pretty high. But we risk assess them in terms of how close are they to crossings, what size dip angle have we got at the moment, and so on, and identified which ones were highest risk, and then started to work through them. We also created an S&C strategy document specifically for the junction, control measures that we put in place through that while we tried to get on top of the highest risk joints was things like we tightened the actual limit for dip angles. So we committed to ensuring there was no dip angles over 20 millirads throughout the junction, where standards would only require you to intervene at 40. And we implemented increased ultrasonic testing regime on the joints as well to guard against any star cracks, etc., that might be developing. And then over the years as well, we've had various tamping shifts and then multi-purpose stone blower shifts as well, using disruptive access that we've been able to agree. So the highest risk joint of all was this one at 735. This is actually after we'd moved it. So the original joint position is circled, and this is the old crossing that was taken out. So that joint was very, very close to the crossing. It was actually right in line with the crossing apron. And that was causing such an issue that when we replaced this crossing before moving the joint, the brand new crossing apron actually cracked within a week. The construction of the joint as well was not ideal in that it was within the check rail. So there was two fish plates, one outside the check rail, one outside the running rail, and then there's a packer in between the two with extra long fish bolts. So very difficult to maintain that. So and it was an IBG as well, which further complicates matters. So we managed to get permission from the signaling team to move that joint several beds out with the check rail, which ends about here, and then we got a bespoke crossing made up, which came all as one, ready to build up that IBJ. And this was the result in terms of the traces. So as most of you will know, track geometry traces, the smoother the trace, the smoother the track. In particular, the dip angles, which are highlighted in yellow, see quite a significant improvement in 735. So really quite a successful job, as we would expect, by moving the joint away from the crossing like that. Just put these in as well. This was something I spotted when I was pulling the slides together, but looking back at 2014, junction looked like then in 2025. Actually, I'd probably venture to say that there's still quite a lot of voiding there, but I think it looks a bit better than it did in 2014, which going on, in fact, that's 11 years later, and there hasn't been any significant refurb work in that time. I think it's probably quite a good endorsement of the steps that we've been able to put in place over the years. So this one is risk assess and prioritise. So when you've got 60 joints, you're not going to get rid of all of them. So work out where your highest risks are and tick them off. Derailments then. This is something I have been involved in a few actually. Luckily, well, one's too many. One of them was on my patch. The others I was sent up to investigate. First one being Stonehaven, which was on the crossover just south of the station. The front of the train had gone one way, the back of the train had gone the other. So my part in that one was to go up and try and work out whether I felt there was a track defect or not. The RAIB were on site there as well, which was a good opportunity for me to shadow them and really understand just how thorough and painstaking the investigation processes are. The cause of this one was ultimately determined to be signaller error, coupled with some miscommunication with the driver. So the signaller had actually managed to move the points while the train was traversing over them, moving back into the station on a shunting move. It's an old mechanical layout, and the interlocking actually permitted that. Second one, Dunkeld. This was a bit strange from a derailment point of view because there was actually no train in sight by the time I got there. The train had re-railed itself and carried on going for 10 miles into Perth before being stopped, come off while trailing through 13 gravel points at the bottom here, and then sort of the trail of destruction, breaking various rails, sleepers, base plates before being dragged back onto the track when it hit the next crossing. It was a railhead treatment train that had come off, and the reason for this one, although I wasn't able to work this out when I was on site, it took a few days till we got to this conclusion, but it was false flange damage on the train wheel. So the back edge of the train wheel had essentially hooked over the running rail, and as it had gone trailed through the set of points, it was a converging stop rail. Back edge of the train wheel was hitting that stop rail, pushed it outwards to the point that the jaw blocks going through the switch just gave way, and the wheels dropped into the forefoot. So that was very much train wheel condition that caused that derailment. Coatbridge, Sunnyside, this was probably one of the low points of my career, definitely. This was in my area. This was an 053 related derailment. It was an empty coaching stock. Nobody was hurt, which is my saving grace. But as I say, what happened here was a failure with the contact angle of the switch. There had been an inspection that hadn't been done properly a few days before, so that was all dealt with and separately. But it wasn't a 4-weekly inspection, and given the level of the failure, it's likely that there was still an issue in previous inspections that hadn't been picked up by other individuals. And the strange thing is as well, we were all inspecting the switch on site after the derailment had happened, and we didn't find the condition either. We had a derailment specialist come up from Milton Keynes and use an electronic measuring device called a mini-prof, which traces out the profile exactly. That picked up the issue very quickly, and we then took the action of recovering all of that steelwork, and we took it to the depot, and it's still up in Kyllius to this day. It's all been built up into a panel, and we now use it for training and learning from the event. But as I said, we couldn't identify the failure on site. Now we've put it back together in the depot. It's very, very obvious, which is very strange and something I've never quite been able to explain. But I think it highlights the value of having an automated inspection for measuring the contact angle using the mini-prof device. We've got laser scans now as well, which are far more consistent than the manual TGP profile gauge that we still use for the majority of inspections. So there was a lot of learning to take from that one, certainly. The other one note with that was that I always remember was the point of derailment was very, very difficult to spot. And it was the derailment specialist that eventually saw it after trying himself for a couple of hours. And it was the tiniest little score on the top of the rail as the wheel had come up and climbed over. It looked like somebody had got a drawing pin and just done a little score, almost nothing. So amazing that a train can do that little damage climbing over the top of the rail. One last derailment, which was at Craig Inch's Yard in Aberdeen. This happened during a propelling movement. And again, my place in this one was to be sent up just after it happened to investigate and try and determine the cause. I've been to a few others by this point and watched the RAIB people, so spent quite a bit of time tracing out the different wheel paths, which I've tried to show in the diagram here, and identified the point of derailment, which coincided with a static twist of 43 millimetres and signs of movement as well, so a bit worse than that in reality. The interesting thing here, I suppose, is that the first eight wagons had passed over successfully, well, actually the first 9, and then the 10th came off, and then the wagons after that and the locomotive, which was propelling the movement, all passed over safely as well. I think the reason why that happened was because the front 10 were empty and behind that were loaded, so there's some kind of dynamics at play there. The interesting thing with this one too is that although both A and B here had come off, it was actually B that came off first and eventually dragged the wagon in front of it off. And I think it would be easy to turn up and make an assumption that the first derailed wagon was the first one to come off, but this one just shows that's not always the case. So learning point for us, point of derailment isn't always obvious. To take a long time to make sure you've identified that correctly. And it also takes a very long time to re-rail a train, was something I find out too. Stonehaven in particular, we all seem to think it was going to be on in a couple of hours, and 12 hours later we're still there waiting to get going with the recovery. Just a quick one, and this is a bit more off the track discipline, so vegetation challenge. This is moving into the IME role. Vegetation is just a massive part of maintenance at the moment. There's all sorts of different problems vegetation poses to the railway. So the straightforward one, which is the obstruction of tree across the line, that doesn't actually happen so much these days. Signal sighting is important. Overhead line trips or damage. Coming into the autumn period, your adhesion for leaf fall, track circuit failures as well. So the leaf fall not only causes the adhesion issue, but prevents the track circuits from working properly. Dead and dangerous trees is a big area of focus. We have surveys that take place and identify the most dangerous trees, which are then expected to go and fell. And public service requests as well. We get a huge volume of those people with have vegetation growing into the gardens and so on that are looking for it to be removed. Storms have a big impact in this field too. So Storm Eowyn, 154 trees down in the Glasgow area, and forests in August was 84 trees, which takes a bit of removing. I think possibly where we need to go with vegetation going forward is trying to find a way of making sure that we're dealing with all the little problems. Feels this year the majority of our issues have actually been from relatively innocuous things like bushes growing out of walls and so on. I think we have gone a long way to control the risk of really big trees, but we're seeing a lot of impact from overhead line trips and that signal sighting as well. And that's what's pulled out as a learning point in that one. So just be careful not to let the small ones take over when you're trying to deal with the big problems. Final case study, you'll be glad to know perhaps, is a multiple track circuit failures at Shields Junction. So this is something coming from a track background and you're suddenly involved in a big complex track circuit failure is a little bit intimidating to say the least, but what was happening here was we were getting intermittent failures of multiple track circuits across this whole red area, which some of us will recognise as Shields Junction, coming out of Central onto the airlines. That was happening in October last year, and it went away basically before we could identify what the cause was. April time, all came around again. The issues, we knew they were somewhere within the data link. The data link is obviously part of the signalling system, and it's how information is transmitted from the signalling, the interlocking and the signals commands out to the trackside equipment. So what we did with this one, because it had gone on for 2 or 3 days, intermittent coming and going, so we got everybody we could think of in a room and sat down and said, where do we go with this one? And the consensus was, well, we don't really know where the issue is. The data that we have is pointed in all sorts of directions, so let's be systematic. Let's get around the detailed tactile tests and inspections of cables one by one, and check all the key known weaknesses and start to work through the problem. So we did that, and we found all sorts of little issues actually, but damaged bits of cable, loose screws on surge arresters, sorted all of that. We had a much clearer picture, but we still had a problem. And eventually, what we narrowed it down to was an overhead line issue, believe it or not, which was interfering with the signalling. So this is a circuit breaker switch on the Burma Road line, which is at a slightly lower level than the airlines. And the first picture shows that it isn't quite shut, and the second one is. So what we think was happening there was that there was electrical arcing interfering with the signalling cabling, which happened to be closer than it normally would be to that switch because of the split level of the railway in that location. The lesson there I've put in is just bring the right people together to solve the problem. So just to wrap up then, key medium to long-term challenges for me in railway maintenance. Financial climate goes without saying. Money's quite tight at the moment, and understandably, I think across the country as a whole, and I don't think that's likely to change in the near future. So we have to find ways of managing within that. Maintaining an aging asset, that almost follows on from the financial climate. So we're not going to get as many renewals as we have. So we need to be proactive, efficient with the resource and make that asset last as long as it can. One of the ways we can do that, I think got room for improvement, is improving our approach to railway as a system. So making sure that all the disciplines are aligned. I think so too often we all do our own thing. Climate change is a big influence. We need to make sure our assets can cope. Spoke a bit about flooding earlier. Heat's a big thing too, and we're seeing higher temperatures, which we need to be able to cope with. Getting the track access balance right. So operators often want more access to the track. Maintenance often want more access to the track. So do renewals and so on. So getting that balance often is a solution where we satisfy both parties, and we've started to move recently to longer blockades, which I think is quite a positive thing. I think the public respond quite well to knowing exactly what's going to be happening, rather than going to the work in the morning and not being quite sure if they're going to get home or not. And what structural changes will we see in the rail industry? I don't know the answer to that, so if anyone's thinking of asking me a question, but we've obviously got GB Rail on the horizon, so that could be a big change. It remains to be seen. And finally, the advice I would have for any maintenance engineer, first one is have a routine and protect it. So you get dragged all over the place, all sorts of things come up that you didn't expect. So it's all the more important to make sure that you've got some kind of routine in place and make sure that the day job, the critical key tasks get done. And for me, that was always achieved by religiously sticking to my weekly team meeting. It always happened, maybe missed it once or twice over 8 years. And I find checklists very useful as well, just to make sure that you're checking all the right places, right things once a week. Be persistent. Sometimes you just need to keep chipping away at things. You can't change the world in a day. Be ready to spend money effectively, although money is tight. In the environment we work in, funding packages do tend to appear from time to time. So if you've got your idea ready to go in advance, you're in a good position to snap that up and take advantage of it before somebody else does, and monitor data over the long term as well. So part of what I mean by that is always take the time to look back at where you were 2 or 3 years ago. That can be really rewarding, because you can get lost in your day-to-day challenges and feel like you're treading water perhaps, and it's often surprising to look back and see, like the photos of Cowley's West, for example. Actually we've made quite a bit of progress there, and we've moved the dial in the right direction. So that was really it from me. Spoke for a wee while there. Hopefully that was of interest, and certainly happy to take any questions or comments if anyone has them.
Thanks, Tom. Anyone got any questions in the room?
You mentioned, Tom, track access.
Yeah.
The being of a maintainer's life. I know that Glasgow was involved in the Initiate trial.
Yes.
How did that go? Or how is it going? Have you found it's made a difference to the track access that you're getting?
Yeah, it does certainly give us it. So you're looking at 20 minutes or so extra in time, because you don't have to wait for the boards to be laid out. Initiate, those that don't know, it's a system that's built into the signalling system, and it allows your additional protection to be applied remotely. So we no longer have to go out and put boards down. In true railway fashion, there are some complications in terms of having to specify exactly which points that you need to work on, which makes the planning a little bit more inflexible, put it that way. And where we have machines and work sites, you're still having to put out ES marker boards, which can, depending on the situation, negate that benefit a little. But certainly it's been quite promising early signs. And it's now at the point it's actually going to be rolled out across the whole of Edinburgh Signalling Centre, and it's coming to Yoker too from spring next year.
Mentioned the 53 and 54 inspections when it comes to S&C. How much is there in the way of train mounted inspection in terms of picking up defects? Is that something that happens? 53
and 54, no, we don't have anything train mounted. We did have a recent, we've tried a piece of kit called the Felix, which comes from an Italian company, Lincone, is it? I think that's right. And that does the 53, it does a sort of scan of the switchblade as it runs through the switch. It also takes gauging measurements and so on as well. The drawback of it is it's a very heavy piece of equipment. It's right about 500 kilograms. It comes in modules, so you don't have to lift all that at once, but it's a lot of weight and very bulky to transport around. So far, we've certainly favoured the laser type. There's an Adtis laser gauge, for example, which is far more portable. One person can easily carry it around. And the mini prof device as well, which is a mechanical device. Electromechanical is one way to put it, and it mechanically traces out the profile of the switch and converts that into a plot on the computer.
Right. You said that one, the mini prof deployed from Milton Keynes. Do you have?
We have that. So one of the things that came out of the Sunnyside development was that we purchased our own. So we don't. It's quite a lot more time consuming than doing the manual inspection method. So we don't use it for every inspection we do. But where the inspector goes out manually and has a bit of doubt or thinks that's looking a bit iffy, we then follow that up with the mini prof and get an exact measurement. And sometimes it actually saves us from needlessly grinding away a switch. Because the manual inspection will sometimes tell you that a switch has failed, and that's to do with the way that we're measuring the contact angle. So it's a TTP gauge and a feeler gauge. The thickness of the feeler gauge is 100 microns. It's very thin, but it does make a difference to which contact angle we get. The mini prof strips that anomaly out. So sometimes we'll actually fail a switch with the manual gauge, and then the mini prof allows us to say that's actually passed, so we can leave it alone.
Couple of questions from John Sharkey.
Yeah.
He's asking, do the air points in Glasgow Central still cause issues? He's thinking about spare parts.
In a word, yes. That's alluding to electro-pneumatic points in Central, which are now essentially an obsolete asset. Only really have them at Perth and Glasgow. There was a load at Kinmure down in Carlisle, which have now been taken out, and we got a load of spares from there just recently, which has helped us. But there are a few risks in there, shall we say, in terms of spares availability. And our S&T maintenance engineer spends a lot of time with one of our suppliers trying to get various solutions over the line, product approved and so on, just to guard against that.
Right.
And one of the other things that we've been pushing for within maintenance, but it's nothing really fixed yet, but we'd like to start seeing some of these electro-pneumatic points converted into clamp locks or some other solution, just to remove that risk. And so if you convert a set of points, you can take the spares off that set of points and start to build up a bit of resilience.
Okay. The Perth's a bit to be.
Yeah.
You might get
So
some
that's
spares out
another
there.
opportunity. Yeah, exactly.
John's also asked how the slab in Queen Street Tunnel is holding up.
Yeah. It's better. Quite a lot better than it was a few years ago, I would say. I think, and a lot of that work gets done by the track run. I fund a lot of a slab track team essentially, who are dedicated to doing sort of spot slab repairs, which has been really quite effective. They also spent a lot of time just replacing pads and clips, which was something that probably up until about 2020 time, when it was seen as a maintenance activity. But when you've got that number of deaf reels to deal with, it's very difficult to do the things like changing clips and pads.
Yeah.
So done a massive volume of that. It's really helped in it. And a lot of the re-railing work that I mentioned as well was in the slab track tunnels. So we actually dropped and installed 40 709s in the Argyll tunnels. I don't have the exact number, but we've been 15 or 20-ish in the Queen Street level tunnels as well. So all of that's in doing that, you're renewing clips and so on and helping that. But certainly we still have a number of problems come up from time to time with the slabs. It's a very challenging asset.
Question from John McCaffrey. Is there any progress with ScotRail adopting UGMS? The Class 153 VIU will be coming to Scotland next year, and the new yellow fleet coming years later. What do you think would be the most beneficial long term?
Well, not actually sure. Is it UGMS?
UGMS, yeah, I'm not
You might
sure.
need to come in, John, and tell me what that is.
Don't know either.
If you're there. But I can fashion an answer. Maybe not quite answer the question, but the Class 153 certainly I think it's got a lot of potential. We've had a trial of that, so it's a train that can measure geometry, and it's got forward-facing cameras, and there's potential for AI algorithms to recognise what all your scrap rail and so on. And so, one of the benefits I see, apart from your information it gives you for maintenance, but I think it really has potential to help us with verifying our data records. Obviously, they should all be good anyway, but the railways change a lot over the years, so there's certainly areas where our records and knowledge of the asset could be improved a bit in terms of locations of joints, adjustment switches, all that kind of stuff. And I think there's real potential for it to help us improve in that data quality.
Yeah. I know in the news world we use the U2U trial on the IDR system, and it's been great for being able to have a look at imagery to really look at high detail.
Yeah, so that's something that, again, that was kind of coming in when I moved away from being a TME, but certainly I know my TMEs use that quite extensively. You get a really detailed downward facing view of the track, and you get a view from either side of the rail as well. So you can really, you get a bump on the line reported or something, and you can quite quickly go in and see what's happening. Obviously not, it's a few weeks behind, but get a good idea of what's there on site.
Yeah. Question from Tony McKenna. Hello Tom, since your time in maintenance, in your opinion, what has been the one key benefit in making maintenance easier or better?
Well, it's hard to pick one out, but I've always been a big advocate for the 4 weekly geometry recordings. I think that, and to be honest, when it first started happening, I was a little bit resistant because it felt like we used to get 26 weekly or 16 weekly normally, and that felt like a lot of work to deal with that. So when someone then tells you you only get that every 4 weeks, you think, oh, no, I'm getting that workload every 4 weeks. And at first it is challenging because you've got a wave you have to get over. But having that 4 weekly recording really increases the quality of your track, because you make your repair and you find out very quickly did it work or not. Mm-hmm. And a lot of them don't work. A lot of your repairs don't work, or you go to the wrong place. So at first, but you learn from that very quickly because you get that next round of information in, and over a relatively short time period, you'll actually see, in my opinion, you're likely to see a number of faults come right down and have a much better quality asset as a result. Yeah. So I think that regularity of data has probably made the biggest change. I would kind of temper that a little bit just by saying you have to be careful when we're producing all of this data, that there's actually systems in place that people can manage the data, because it's no good just firing more data at a poor maintenance engineer or a section manager over and over again and expect them to analyse and deal with it.
I suppose even if stuff that's not in your patch, there's a data trail of where things have worked elsewhere as well. Yeah,
exactly. And it's a real comfort as a TME that you're getting that reading every 4 weeks, because that train's telling you a 15mm twist, which is well before the point that it becomes truly dangerous. Yeah. It's giving you that warning every 4 weeks, and so you're really comfortable as to the speed of deterioration of your asset. It's really good. And I suppose it was before my time a bit as well, but certainly the ultrasonic training was already in when I started, but that's something that it's made a massive difference too, in terms of its ability to identify internal defects and prevent leaks. So, yeah.
John McCaffrey just clarified there. So UGMS is unattended geometry measurement systems. It says they're fit to some of the Avanti Pendolino fleet, just to fill in the gaps between TRU runs. Okay. And it's linked to Insight.
Right, yeah. Sounds like it's got potential. I think I've not been involved, so I can't really say too much, but I think that my boss has actually been engaged in some discussions around starting to integrate that data. But Avanti, of course, don't cover it. We've only got about 4 miles of track on the West Coast mainland, so need to be scored from us.
Yeah.
Eastern are doing some stuff in that respect. Saying that within the 153, they're doing some sort of daily track measurement,
right?
VR run along the East Coast Main Line. So there's loads going on. So like all different areas doing amazing stuff.
Got some good feedback, Tom. Pleased to hear. Greg McMillan saying, great presentation, Tom. Great to hear from someone on the maintenance side of things. He's been missing PWI Glasgow for a long time. Also great to hear the mention of off-track. The whole of the world and covers a multitude of topics on the railway. Mark Taylor, thank you. Valuable insight into the work you undertake. Great to hear about your attitude to solving problems. And John McCaffrey also posted an invitation to the Queen's Garden Party, which was received by John Smith for noticing the Ardley washout.
Yeah.
He posted that in the chat. Any more questions in the room? No? Well, thanks very much, Tom, for your presentation.
Welcome. Thank you, everyone.
Very interesting. It was gave a good flavour of the sort of challenges that maintenance are dealing with. Sounds like you've got a really interesting job, but I bet it's not without its stressful moments.
No, definitely not. Anyway, that's what I like about it. You don't quite know what's going to happen each day. That's a surprise around every corner.
Yeah. No, thanks very much for presenting this, and if we just join in giving Tom a wee round of applause. Great. But maybe one more question. I'm just been told that I missed one.
Right.
From Greg, they said it's clear that things like AIVR used for DLI and other systems will get a great benefit. However, once upon a time, joining the railway, especially PWI, allowed you to see the country or a fair amount of it. What's your thoughts on the move towards sitting watching a screen instead of being out there on the ground, experiencing the railway in reality rather than digital version?
Well, that's a hard one, but my instinct is that I don't really like the idea of sitting and looking at a screen.
Yeah.
You do get a feel for. I always like doing my cab rides because you really got a feel for just getting out and about, seeing a part of your area in a relatively short time. And as a maintenance engineer, you would walk your whole patch every 2 years, which felt about right.
Yeah.
So I don't think I'd want to lose that, to be honest, that 2 yearly walk around. In terms, however, of your weekly inspections or your more regular inspection regime, it's probably got a lot going for it, because humans are human, to state the obvious. And if you're walking the same piece of track every week for week on week on week, you're inevitably going to start to switch off a little bit. A machine never switches off, so
Yeah.
You start to get that benefit in terms of consistency, and probably even these AI algorithms and so on, they might miss one problem out of 10, but the human would probably miss more than 1 out of 10 if they're walking mile upon mile of track as well.
Yeah.
So.
I suppose not everyone's nice to walk this Bridge of Orchid to Mallaig as well.
No, and you're walking up there, you need to remember to look at the track.
And one last question that I missed as well from Jordan is asked, what was your favourite project to work on so far in your career?
A favourite project? Well, it's thing with maintenance is it's say my favourite role. They've all had their plus points. I'm going to say my most recent one, my current job now, which surprised me because I never really wanted to leave being a track maintenance engineer, but I've actually really enjoyed, on the whole, moving up a level and just getting that involvement in different disciplines, learning about new things, which you always are anyway, but completely new things, and just getting an opportunity to hopefully be a little bit more strategic, I suppose, which is quite a good thing, I think, as you move on in your career.
So, right, that's good. You can stop recording now. Thank you everybody online for joining. Appreciate it.
Thank you.
Okay.